Great. Welcome, everyone. My name is Jules Urbach. I'm the CEO of OTOY. And I just want to get a show of hands. How many people are familiar with Octane and OTOY? Oh, almost everyone. Great. Well, there's a few that didn't raise their hands, so I'm going to give a brief overview about OTOY and what we do. Our mission is to democratize rendering and content creation, ultimately with the goal that we're all going to end up in something like the Star Trek holodeck. Obviously, VR and AR are approximations of that. And rendering is getting really interesting. This year has been an amazing show at Siggraph with the announcement last night from NVIDIA. But Octane is a product that we've been working on for a decade. It's a spectrally correct GPU path tracer. And it has been integrated in Unity for exactly 1 year. Siggraph 1 year ago, we announced Octane inside of Unity for free. And for those that haven't seen Octane, this is the kind of stuff that it delivers. This typically, people use Octane in tools like Cinema 4D or 3D Studio Max, and they create beautiful film and television works, such as the ones that you're seeing here. This was actually done by Elastic for The Crown. And also, you saw the opening of Westworld, The Alienist counterpart. There's a lot of shows and television work that's done with Octane because basically GPU rendering compared to CPU rendering is way faster. And on television deadlines, I think the workflow makes it a lot easier to justify sort of switching from the decades of CPU rendering to the GPU. We are really proud to announce at Siggraph that Octane was used to actually do the entire 40-second title sequence, credit sequence for Ant-Man and the Wasp. It was also done by Elastic, 4K left and right eye. It was actually, I think, one of the only shots in the film that was rendered left and right eye, roughly, I think, 15 minutes a frame in Octane 3.08. So Octane is absolutely ready to be used for film and movie production. And that's why it is super exciting to consider the fact that that same renderer is exactly what you have in Unity. In fact, Unity has been at the vanguard of pushing out new releases of Octane. It was the first integration of Octane 4. But our goal is to get millions of Unity developers that have any interest in cinematics and rendering and art to basically have the same tools that Marvel and Disney use to render their biggest movies. And so as we look towards the next decade, and I think the 2020s are going to be really interesting, the trends that I keep going back to are, well, things will look photorealistic. I think the keynote last night from Jensen really made the case that there's almost no reason for things not to have ray traced reflections, for things not to be real time. I think further, you'll see a lot of interface and complexity and even code and other things going away. I think both tools, development, and content is going to be very intuitive to use. It should not be as complicated as it's been. And I think that a lot of tools are successful, especially with the disruption I think Unity is providing in the content creation space because of its simplicity. And I think that AR is also very important in the short term to sort of figure out what these holographic mixed reality experiences will be. And I mean AR on a phone because hundreds of millions of people have phones. So AR kit's a really interesting target for us to explore all of these. And you'll see some of the work that we're doing on the iPhone and on Tango. Well, now, of course, it's AR Core. But I want to talk about our technology roadmap and how that impacts Unity. The bulk of this presentation will discuss the new version of Octane and how that is going to change a lot of artist workflows, I think, for the better. So we've been releasing Octane for 10 years, started in basically 2010, and every generation, every iteration that came out every 2 years added other important layers. And Octane 3, which you saw used for those incredible cinematics, I mean, I think at that point we were production ready, and that was pretty much validated by us doing a Marvel film. So Octane 4, which was released in March, it's only been about 6 months since it's been out, is all about real time. And that's why the integration in Unity was so important to us, because we wanted to provide real-time path trace graphics inside of Unity Editor and ultimately into Unity games. And for the future of Octane, and we do have a version 5 revision of the engine that is in Octane 2018, we think that holographic rendering is going to be really important. By that, we mean rendering to light field displays, rendering to formats that can basically be decoded very quickly, even in AR. So you'll see all of those examples inside of Octane for Unity in this presentation. And of course, one of the things that we can't ignore about the future is we do have ray tracing hardware. So I've been a big proponent of that. 2 years ago, I said Octane 4 we'll have ray tracing hardware support. It was actually, we were just testing it on a prototype chip. But I lost my mind when I found out that NVIDIA was putting that kind of hardware in, in the RTX chips, and it is 10 times faster. It's 3 to 8 times faster in our tests. So I'll be giving a presentation today about our results on that at the NVIDIA talk later. But it's a game changer, and so you probably can justify saying that yes, ray tracing probably has been advanced by 7 to 10 years by having ray tracing hardware shipping in a major GPU like NVIDIA. So I want to talk about Octane 4. As I said, that was released about 6 months ago, and release candidate 1 is out today. So we're very excited about that. It's feature complete. Every single thing that we wanted to do inside of Octane 4 is now there. And after 6 months of testing experimental builds, I think we fixed all the bugs. So it's pretty great to be at this point, and that was also where we felt we wanted to be at Siggraph so that we could comfortably talk about what's coming next. But just to recap what made it into Octane 4, there was a lot of amazing technology. Some of it I haven't seen anywhere else. So Brigade engine is something that we've been showing at Siggraph for years. This basically was a test that was done on 80 GPUs initially. And that was the equivalent of around 3,000 Octane bench. That's about 10 Titan Vs. And we're now at the point where we could do that on a few of the RTX cards, which is really cool. So this is all path traced live in real time, and we didn't even have technology we have today like the real-time denoiser and other things that make this work much better. There's still a little bit of noise, but it's very, very, very small. And I think that we were always looking at Brigade as being something that we wanted to blend with Octane's quality, and that's why we decided that rather than shipping this as a separate product for path-traced games, like let's just get this into Octane, let's get Octane and Brigade to be one product, and then see if we can get that into a game engine. And of course, Unity was our first choice. We've been thinking and discussing that with Unity since 2014, and so having it ship last year and having Octane 4 now in Unity shipping this year is great. And we've, one of the things that's been really interesting with Brigade is that we did test it very early on with things like bullet and dynamic objects. So you're able, even on non-RTX hardware, to deliver path-traced games and the like with noise. Now, one of the really big improvements that's happened in the last year on our side and also with NVIDIA Optics is we have AI-based denoising. So what you're seeing here is just 50 samples, and you have a final quality frame in 1 second. So this denoiser that we developed for Octane is for final quality output. It's not meant to be necessarily in real time, but it certainly shows that we're nearly there. And there is work that we're doing to try to get denoising and even rendering to be much faster on RTX. That's still in progress, but even on Pascal and Volta, the results are pretty stellar. And we had some really cool features that allow you to create planetary atmospheres, space, all these things are there in Octane 4. We created a universal Uber material, mainly so that we could have better integration with Unity. Our material system in Octane 4 now is a really good match. And a couple of extra features made it in that were planned for the later releases, and that includes light linking and exclusion, very important for motion graphics, and UDIM textures. GPU texture compression, really important. We can compress textures in Octane 4 8:1, and we support multi-layer EXR as texture inputs. So you can download the first build of Octane Release Candidate 1, and it'll be shipping in Unity in about a week. It'll be the very first RC1 integration. So inside of Unity and 2018.1 and later, we've added some deeper integration with Octane 4. We basically have the ability now to bring in scenes from any of the 26 tools that Octane supports and is integrated in like Cinema 4D, and you can bring in basically not just a proxy that renders only in Octane, but it'll actually convert the Octane scene into a mesh, drop it inside of the Unity scene graph, and you now have parity. And having universal materials in Octane means that the material system between Octane and Unity is really close. So obviously with the HD scriptal rendering pipeline and the great work that Natasha's doing, sort of advancing the state of the art for real-time graphics in Unity, like we see that as being a really good fit for Octane. We do have GPU light map baking, and that's something that we still think is really, really, really useful, even with other solutions inside Unity. We have, for example, AI denoising on the irradiance pass now in Octane 4. And we're going to keep working on integrating more and more advances into the material system in Unity as the HD scriptural rendering pipeline evolves. So the very first test we did, of course, was we wanted to make sure that we could drive the Siggraph in the Octane viewport on par with what we can do in the Unity viewport, and we can. There's still a lot of work to be done. We need callbacks and other things from Unity, and we've been working with them for a long time on enabling those things. So that really is one of the only issues that's sort of blocking us from putting out a runtime build of Octane 4, that would basically allow you to drive your games in game mode. But I think we're close. And I think as we look forward to the next version of Octane, we have a lot of crazy stuff coming, which I think is fantastic. Some of the features that we didn't put in Octane 4 were really things that are just created and invented really just to make Octane a lot more fun to use and to give artists things that they just didn't have in their toolbox before. So Octane Render 2018 is the next version after Octane 4. We are moving, like Unity, to not having big version number releases after Octane 4, because we think we're going to be putting out major versions every few months, at least twice a year. So in fact, this year we started with Octane 3. We released Octane 4. That's now shipping. And we have a 5th version of the engine in Octane 2018. So under the hood, there is still an Octane 5. It's a pretty big update. But that's 3 major updates in a year. So that's why Octane 2019, 1, 2, and 3 will probably be a better way of sort of tracking Octane's progress going forward. So the new features that are in Octane 2018 are pretty cool. And our focus for this release was to give people really fine-grained control over procedurals, both procedural light and procedural geometry and shapes. So Vectron and Spectron are 2 new technologies that we developed, and they're really cool. So Vectron is basically an uber primitive. For a GPU path tracer like Octane, it's expensive every time we add a new primitive type. In fact, Octane 1 was much faster than Octane 3 because we had only one type of primitive. When we added things like motion blur and displacement and also spheres and other things, hair primitives, these things, it's tough on a GPU. So we wanted to make sure that at least going forward, we could have just one primitive type that covered everything. And so Vectron is basically a vectorized primitive type. You can basically create any mathematical function in OpenShader language, which is built into Octane, and create meshes or volumes, and it is super cool. One of the things that's awesome about this is that it takes up 0 GPU memory. That fractal that you saw took up no memory on the GPU. It's basically being generated and rendered in real time. And the calculations for generating it happen in the OSL compiler that we wrote for Octane. So it's happening on the GPU, which means you can change that fractal. You can do dynamic things with it. And it's beautiful. I mean, this kind of stuff is awesome. There is absolutely no triangles in the scene. It's just one object that is defined by a 5-line OSL shader. So there's a lot of cool stuff that comes with this technology. You can create complex shapes, volumes, but you can also create operators. So you can define how one fractal object and a sphere can combine together, and those can also be in OSL. So you can create node graphs that can be really, really mind-blowing. And the other thing that we are adding into 2018, into this version, is the ability to take, for example, OpenVDB volumes, which can already be loaded into Octane, as well as meshes, and you can vectorize them. So imagine when you take an image and you turn it into a Illustrator file, and you get nice curves. We're doing the equivalent for meshes. And we also have the ability to take something that is generated in Vectron and spit it out as a volume or even a mesh, but it'll only be an approximation, and it'll be very heavy. So the real value of having the vectorization pipeline for meshes and volumes is that once they're in this form, we can actually do some really cool stuff with them. We can basically do Boolean operations. We can make metaball operators. We can reskin them. We can do insane procedural surfacing, basically for free. So the other thing that we've also been able to accomplish with this is that we don't need to create more primitives, even for things that we already had primitives for, like spheres. We can get rid of that, and we can just use Vectron for that. We also have the ability to render strands and fur and things like that, and we definitely have an alternative now to doing displacement maps or vector displacement. You can do a lot of those effects in Vectron without even having a mesh at all. And just in the few weeks since we've had this working, because this is all very new. We've built some really great examples, some of which we're showing today at the booth and in this video. And I'll go through these. So the first thing is this fractal that you saw before. In Vectron, there's now the concept of time. So you have not just the ability to render something in space, but you can see in the shutter time, I can change the, this is basically rendering in time and space, which is super cool. So you can control exactly what happens over time as the procedural is being rendered. You can also control all the different things through open shader language that can be fed into this. And this interface is exposed inside of Unity. You can basically get the, the Octane's node graph right away, but we're also working on making sure that Vectron nodes are exposed inside of the Unity interface as well. That work is starting shortly. So that's a metaball. That's me playing around with infinite planes. It's just a planar OSL surface that basically can then be modified with all the procedural textures that are, by the way, also 3D. So you can just play around as an artist, even as almost this childlike way of just experimenting with different things. And it's really easy. These are really fun things to play with. You can even take things from ShaderToy and you can try to convert that to OSL, and some of them do work. But you have things that I've never seen in any other ShaderToy type system, which is that this is integrated in a production-ready path tracer, and you have things like time. You have all these controls over the spectral domain as well for lighting, which is just absolutely awesome. And the way that we see Vectron working going forward is that people probably will, just like ShaderToy, can contribute very simple OSL nodes that can then be published and shared and distributed. And we did that to some degree with open shader language textures, but I think that this is going to be even more powerful. And you can see here we did some tests where you could do procedural oceans now with foam and other effects really perfectly rendered. And you can see Vectron shapes can be mixed with a real object like that teapot in there. Infinite trees, again, just a shader. Super cool stuff. Zero memory used, zero triangles used. So it's a pretty amazing piece of technology. It's also, as I said, you can use it for operations. So this is showing something where you can take two vector objects. One of them is this procedural sponge-like object. The other is a sphere. And the sphere is essentially cutting out the larger object. And that's defined in a Vectron operator. So as I move the position of the sphere, you have perfect vectorized, very smooth Boolean operations, which is great. So when you imagine vectorization of meshes and doing these kinds of operations, a lot of effects that have been really tough to do become very, very, very simple, very fast. And it's something that is genuinely a lot of fun to play with. So anyone that's interested by what they're seeing here should definitely stop by the booth at Siggraph and play around with the first build. So with these kinds of operations, you can also do things that are not just for the geometry surface, but also that are visual as well. So I'll describe that with Spectron later. You can also experiment with existing modes of noise and displacement. In this case, it's on a sphere, and you can see that it's really interesting to see how, if you don't have to limit yourself to a displacement map that's a 2D surface, you can do really cool stuff. You can see the rocks are actually going outside of the surface of the sphere, so you can really just render things in space just from a simple shader and just from mixing noises together. In fact, it's so interesting and powerful that I feel like we're probably going to see the most interesting stuff from users once these tools are out there and in people's hands. So Vectron is one part, or one half, of the procedural system that we're introducing in Octane 2018. Spectron is the other half. And Spectron does for light and energy and anything related to photons the same thing that Vectron does for geometry and procedural surfaces. And the goal for Spectron is to give you artistic freedom. Octane is so correct, in fact, that it actually is kind of slow when you're doing really complex things that seem simple, like a spotlight. And that was one of the complaints we got from Unity users. Where is the Octane Spotlight? Why isn't it exactly like Unity Spotlight? Well, spotlights in games are really simple. Spotlights in the real world are very complicated, and getting these really cool spotlight effects in a physics simulation is costly. So Spectron does give you the ability to shape things, to shape lights into all these things, so spotlights become trivial. And the other thing that we can do with Spectron is, there are things that we want to have that increase the realism, even as we add these artistic effects. So for the volumetrics, we have a build already that's looking really good. And there's a lot of things we introduced in Octane 4 that we're leveraging again in the 5th version of the engine. So we have AI lighting, which allows you to track lights, point lights in particular, really quickly and get noise-free renders very fast. We now adapted that to directional lights and spotlights, or similar things that you can create procedurally with Spectron. And we have a volumetric denoiser as well that's also trained on these new types of light volumes. And then we're also making it really simple for spotlight type effects, which people want for directional lights. Like you can put barn doors on your lights, you can have gels and gobos on there. And basically, lighting now at this, with these sort of very expensive to render lights in a path tracer are now basically real time. So this is one of the first tests we did, and you can see this is all in the Octane viewport running live, and it's so fast that you can basically do operations in real time, and they're noise-free at full resolution. This is showing the barn door effects also live. They're really, really, really fast to converge, and this makes it really easy for Unity users to basically now have spotlights, set those up, and create the volumetric effects that I think they're looking for. To be honest, I think this is going to make it really easy for giant feature films using Octane to also leverage these kinds of effects. It used to take a lot longer for Octane users that have been using Octane to render these spotlights, and it also wasn't really feasible. We didn't have a way of sort of diverting rays and energy to the to the light volume like we do now. But even if you have just a larger fog volume like this with a scene with a complex animated mesh, it's still super fast. It's still basically near real time. And we made these videos before we finished the volumetric denoiser, which we're showing at the booth. That volumetric denoiser basically takes that down to basically real time. So combining these technologies together is awesome. Everything's completely procedural. We have a procedural fractal in the middle of this procedural light. And the light itself is something you can control, again, through shaders. And same thing with the fractal object that you're seeing in the middle there. And what's cool about this is that we're seeing an effect that has been something that's been tricky to do in Octane, because you have something that is so infinitely complex, and you have light that is basically showing off that complexity with God rays. And this used to take forever to render in that first God ray, so we put out Unity. Now it's real time in the viewport, which is pretty spectacular. And I think that the ability to control shapes and lights in real time on 2 GPUs, and these aren't even the RTX ones, which will make this even faster, is just wonderful. So we do see, and we are planning to have all of this be something that runs 1080p in real time on RTX. I mean, we think that that's very possible, even with volumetrics. The one thing that I will point out, though, is that RTX is only accelerating triangle meshes, so it doesn't necessarily help us with this stuff, but that doesn't mean it can't be useful, because typically you are going to have a lot of triangle meshes. That teapot, for example, that could be accelerated by the ray tracing hardware. But even without that, we're at a point where we're able to render these really complex volumetrics and shapes so fast and so cleanly that it's now, I think, totally tractable for real-time usage. And we're very proud of that. And I think that this is something that really is a game changer for everyone that loves art and real time. So on the other side of the spectrum, we wanted to use Spectron to sort of give us a sandbox of new tools, all of which could be driven by shaders, to go after the last bits of pieces that Octane has not yet covered. So if you go to Wikipedia and you look up the rendering equation, the very famous one that defines, every path tracer uses to define how to render, there's a lot of pieces that aren't in that equation. So some of them have always been in Octane. We do have subsurface scattering and transmission, but things like polarization and fluorescence, substrates that, for example, define the boundaries between wet and dry surfaces, diffraction, which is very hard to render. These things are not necessarily in renderers, and they need to be if you're going to absolutely, with fidelity, render the real world. So, for example, in the 5th version of Octane, and Octane shipping in 2018, we have polarized and unpolarized filters and lighting, which is awesome. So that does allow you to do more realistic effects that you would see in the real world. Polarized lighting is something that you can actually control the rotation of the polarization of the light rays through shaders. And it is something that is there both for giving you more realistic renders that are designed to match what you see in the real world, but it could also be used for artistic things as well. The other effect that was on that list is fluorescence and phosphorescence. So Octane actually is a spectral render. It looks at every single wavelength individually. Most renders do not. Production renders do not. Octane's very unique in that way. And we've leveraged that to give you the ability to apply a matrix, for example, to materials. And that gives you the ability to take UV light and make it shine in this way, or have fluorescence in black light. So we have all these different wavelength functions. You could even abuse this and do an X-ray scatter, for example, because you do have now procedural controls over what happens at each wavelength of light in Spectron, and that is super cool. The other thing that is going to be a huge win for artists is layered materials, basically. So we introduced the universal material. Its initial goal really was to be an Uber material for integrations such as Unity, but we're extending it now with different substrates and layers, which I think is also something that's going to be inside of the HD scriptable rendering pipeline. It looks like that's also something that we can then sort of connect backwards to Unity workflows. But in our case, it's something that is really important for realism, and that layering effect is something that completely replaces what we needed to do with mixed materials. And it also is going to help us go after some of the physical effects that we wanted to cover on that list, including porosity, where you have things like wet and dry surfaces and the like. We are also going to be using this as a basis for introducing much more advanced subsurface scattering and hair that is based on our scans from Lightstage, which is our capture facility for digital doubles. Layer materials in general, just from an art perspective, really fun and easy to use as well. The other thing that we introduced back in Octane 3 was toon shading, and everyone loves it, but it wasn't complete. The thing that was missing from a toon shader is that you actually, for things like animes, like production edge uses when they're rendering, you need to have really good edges and lines. And that's something that's harder than it looks. It's something you don't necessarily want to do in post. You don't want to necessarily extrude the geometry. So what we did is we created a whole other rendering kernel, and you can see it here, that does nothing but ray traced edges. And it is actually using advanced ray tracing. If you look closely, you can see that the edges really line up nicely, almost as if they were drawn by an artist. And it's a little different than what you would do in other non-ray traced edge rendering modes. So we're very happy that this is at this point, and we're going to basically ship that with the next version of Octane and allow that to be used in conjunction with toon rendering or other effects. But having a really nice edge renderer is something that I think, beyond just animated content, can be really useful for other purposes as well. And it looks great. It looks really, really cool. So the other major work that we're doing, and this is something we actually used ourselves for the first time at Siggraph. If you go to our booth, you'll see we have a 16K video wall. And even with Octane 4 and the denoising, it was a challenge to render at 16K. So what we did, because we had so little time and so much content, is we rendered it 8K by 2K, and we upsampled it with our AI upsampler, which we're planning to ship by the end of the year. And it's pretty great. I mean, if you look at the if you look at the image on the right and on the left, it's amazing what the AI is able to do. And that basically points towards something that Jensen had mentioned yesterday, which is that, well, just like with optics, denoising, and NVIDIA's other AI efforts, like we have our own in Octane, but I think that it's very obvious that temporal and spatial upsampling is something that AI can do really well. So we're going to work on this further, but it might give us a 4x if we are able to successfully take something that's quarter res and upsample it every frame with AI upsampling as well as denoising. So for sure, you can render at 8K and get out a 16K render that looks just as good as the original. That's pretty cool. There's a lot of other things that are going into the final 2018 release. So one thing that we're doing is meshes will have infinite primitive counts. There's no limit on polygons, even though it's something we were considering putting in Octane 4. It just was too early. But we do have out-of-core geometry in Octane 4, which means you can load anything, any mesh from system memory. As long as you have memory, CPU memory, it can still work, and it's actually very fast. The other thing that we're adding to both Vectron and also just to meshes is the ability to have vertex attributes, vertex attributed user data that you can use, and that's important just for workflows that connect back to Cinema 4D and Houdini. And if there are any Cinema 4D users here, there's a lot of really cool stuff in Cinema 4D Release 20 with OpenVDB. So the core engine itself in Octane will expose everything so that the Cinema 4D plugin and other integrations can leverage OpenVDB operations. And we are also going to be enabling traditional vector displacement and actually displacing meshes from textures rather than doing it as a sort of voxel operation like we've done in Octane 4, because we now have unlimited primitive sizes and we do have out of core. So this feels like it's something that production renderers sometimes use. If they want it, they can use it without any issue in this version of Octane. We are also doing a completely new AOV system. It's going to be, right now in Octane, there's 30 different passes that are sort of fixed, and you'll be able to generate anything you want. You don't have to select from one of those existing versions. You'll be able to do your own, and it'll probably be a little bit simpler than light path expressions, which are used in production renders, but you can probably apply those here as well. We're adding support for Cryptomat, which is really cool technology that Nuke supports for compositing. And even though we do have light linking now in Octane 4, it actually shipped, we are going to add improvements to that around trace sets. And then finally, because a lot of users have asked for it, we are working with NVIDIA to license their rounded edges system, which we will enable in the next version of Octane as well. The last two bits are related to subsurface scattering and hair. As I mentioned before, these are going to be based on measured data that we have from LightStage. In fact, LightStage is used to do ground truth for a lot of production houses for skin and for hair. So we have that data, and we want to basically fit that spectrally to the new hair and subsurface scattering skin material that's going into this version of Octane. And with that in place, we can now do domain-specific denoising for hair and for skin, which I think will be pretty cool. And the last feature on this list was something we tried to ship in Octane 4, didn't quite make it, which is you can take your out-of-core AI scene geometry data, save it to disk, reload it back instantly. And that'll be a big time saver. We'll also be using that for cloud rendering as well. So speaking of which, this year has been a huge year for us in terms of providing Octane as a service. We, without getting into specifics, there are feature films using Octane that have been rendered on the cloud, the public cloud, which is amazing, crazy that we live in this world. And we've been providing Octane on Amazon and on Google for a while through Orc, but there's not enough GPUs. Honestly, we can use, and we are partnered with Amazon, and we know that team very well, and we're working with the ThinkBox team and the like on this. But we do run out of GPUs on AWS just rendering simple Cinema 4D VR renders. Those can use thousands of GPUs if you want to turn that around in a day. So getting that to scale is something that we felt we're just not going to see that on the public cloud for a while. And even our partners on the public cloud are, they're not investing in massive amounts of GPUs yet. It's sort of a chicken and egg problem. So our solution to this was to go back to something I thought of 10 years ago, which is let's let, just like SETI at home, let's let all these millions of GPUs that are out there sitting there playing games or used in people's desktops, when they're idle, let's do rendering on them. And let's take our centralized cloud rendering service and put that into literally a system tray applet you can click to say, I want to render. And we launched, in fact, that system tray applet to beta testers for phase 2 of render in June 30th. And we also had a token sale, initial token sale in October that went well. And we are basically using the blockchain to pay all these users that want to run these render jobs. And we're basically paying them the same thing we would pay Amazon or Google for the equivalent to Octane Bench, which is the rendering power that Octane is very good at measuring because it scales linearly. And it's kind of awesome. I mean, we can't wait. This is something that is going to be super, super, super important in the future as the rendering that we're doing inside of Octane on the cloud stops being 4K frames for films and starts becoming more like the things that really clog up the public cloud, which are VR renders or holographic or light field renders, which are trillions of rays. And even with we need all the help we can get with this. We need RTX to speed things up 10x. We need denoising. We need all these things because the kinds of volume of rendering that go into light field rendering are just enormous. And in fact, the most expensive jobs we've ever done on Amazon that are 150K for a single image have been for light field renders for a client. And the great thing about our integration in Unity is that I think that the Unity integration itself will allow people to play around in a game engine like Unity and create light fields and then have that light field then be brought back from the rendering service and dropped in as a sort of semi-baked asset. So we are, as I said, in phase 2. We're about to go into phase 3. Phase 3 is where we actually give people tokens for their jobs. Right now, the beta testnet allows you to fulfill the work, and we're about to move to commercializing this. And we actually do have sort of an interesting and tricky path ahead of us because now we have a couple of things that sort of throw Octane Bench into different directions. Octane Bench used to be pure path tracing on compute, and now we have things like ray tracing hardware, which increase that by 10x in certain cases. We have denoising, which can reduce the render time by 4x. sort of the good news is that most of those technologies are being introduced on the very same GPUs that Octane's always been running on. And ultimately, we're going to come up with a benchmark around all these things that takes that into account. But right now, Octane Bench and all the renders that are done, including the ones for Ant-Man and the Wasp, are all pretty much leveraging the existing pipeline that we've had in Octane 3. And Octane 4 going into production will probably start to change that. Phase 4, which is next year, is all around, well, we now are taking all these assets and we're rendering them on the cloud or on the blockchain, and there's no reason for us not to leverage that to allow people to define in the scene data what the reuse rights are, what the remixing rights are, and pay those things out as royalties in render tokens. That also is something we're going to leverage for streaming. So we are working with partners like Endeavor, which owns UFC, Fashion Week, all these things, to come up with ways of turning this into a real ecosystem for content creators. We also have an SDK that is designed for generating and building things other than Octane on this blockchain network. So the SDK is something that we've started to use internally. It basically is a cross-platform framework that allows us to bring things like Octane or other technologies onto all these different devices and essentially package them up as modules, which we can then put on the blockchain. And I mean, we can give those out for free, but that's essentially how we're going to sort of break Octane into parts and distribute that in the future. The very first part of that will be the viewport inside of Octane is going to be rebuilt with this SDK. And then over time, we're going to replace, of course, the cloud rendering service, the centralized LiveDB, which is where users can share their assets. All these things after Octane 4 will move to render, and they will be packaged as Urbach files, which are basically a file container that goes into Octane's node system. So the render graph in Octane is essentially being represented by the blockchain, and even Octane itself, the parts of it, the kernels, the different things that are now sort of this monolithic piece, will start to be diffused and distributed as blockchain modules. So the cool part on the tech side of the SDK is we do have these different backends. So Octane started off on CUDA, but we have been trying for many years to get Octane actually to work on the Mac and onto CPUs. The problem is that it's been very difficult, mostly because we haven't had the support in things like OpenCL. We did an OpenCL port of Octane, and then we realized very quickly, oh my goodness, Apple is going to kill OpenCL, so we better look at something else. And in fact, they did. They're actually killing off OpenGL, which shocked many people. So for us, the future of the work we're doing, and probably others that want to leverage this technology that we built, is to have something where you can write something once and then port it to all these different backends. And in fact, for Octane 2019, we are going to be using that SDK, as I said, to start with a viewport and other pieces that we can eventually have all of Octane supported on the Mac, even on iPhones. And in fact, at the Siggraph booth, we are showing the very first build of Octane 2019's path tracing kernel. There's a brand new path tracing kernel that we've been working on that's pretty fast. It's also designed to support RTX, ray tracing acceleration, so those speed bumps I was referring to, those 8x speed bumps come on this path tracing kernel. But on the iPhone, we are now running a path tracer. This is actually running faster than the very same demo you'll see at the on the MacBook. So Apple's GPUs are pretty good. I mean, path tracing, not direct lighting, path tracing. We have Octane Bench running here on the phone. These are iPhone 8s, and knowing Apple, the GPUs will be even faster in the next generation and even faster on the iPad Pro. So putting all these pieces together for workflows that I think are the future of what we want to do with Octane and Unity, mixed reality is a big one, right? So we have provided a service for years that captures objects through light stage. We want to make that something that is basically built into phones. We also want to support, as I said, phone-based AR is really important. And this is an example of how we can take something that's a light stage scan, put it inside of Octane as an Urbach, and then use the cloud service to generate a light field, and then that light field gets brought back into Unity. And as you can see here, it renders perfectly. You don't even need to denoise it. You don't need to have RTX. This is the light field renderer is so fast that it runs on just about any mobile device, and you get Octane quality. But it's big. It's basically like a hologram. It's a single holographic frame. But you could do animations, and we've been working very, very, very diligently to not just bake one sort of basically not bake a hologram from all these different viewpoints with one fixed lighting position, but have something like what Lightstage does, which gives you the material and those properties as well. So even as we're streaming these light field assets down, and it is a stream, you don't have to actually include them in your Unity project, we can do real-time reprojection from the cloud. This actually works. And with 5G and other things, you'll have this working even better, but it runs just fine on LTE at under 2 megabits a second. So the parts about how we would actually use these things inside of Unity game mode is really interesting, and a lot of R&D has gone into that. So we started showing that at Unite Austin last year, where we were taking 2 different light field renders in Unity, and in VR I was able to blend those together. And we were able to do even basic ray tracing. So, some of the things that we're looking at is to use things like RTX and use portions of Octane to finish the rendering, but not necessarily have to do all of it from scratch. That's something that we can do even with these light field objects. And the other thing that we're working on, which is necessary for AR to work well, is we need to have really good scene capture. And ideally, we would put a 2 stereo, 120 frames per second cameras in each phone and have polarizers like we do on the real light stage. We've even built LED block diagrams so people can make those modules, but we want to capture the scene in AR, and here's an example of that done offline, but also captured from photos from an iPad. And here it is running at 120 hertz. This is our office environment back in LA, and we have excellent scene reconstruction. So that's something that shows the quality we can get maybe in offline mode, but we want to have this working in real time. And I've tried the Magic Leap device. Obviously, some of these things exist in HoloLens. They're pretty good. But we want to get to the point where we can take objects and blend them and mix them together in mixed reality perfectly. And this is a test we showed last year. And we also have been looking towards true light field displays. So one of the things that we are able to actually test on the iPhone 10 is face tracking. And for the first time, we were able to really get a sense of what our holographic renders would look like on a true holographic display. And that is something that we do see coming in the next 2 years. In fact, if there's any interest here, come to our booth and set up an appointment. We can show you some of the technology around this that we're developing. But I think that there's going to be glasses-free mixed reality and other experiences that are holographic coming in the not-too-distant future, at least to large venues first, and eventually, I think, to consumers. And this is something that we are showing at the show, and this is basically all of that R&D put into something closer to a product, where we can take something out of Octane, mix that with also Unity as well, and we can do really good mixed reality lighting. So that basically is our Siggraph video wall in our office with a little robot character, but it's being lit perfectly by that environment. And we have some of those demos running on the iPhone at our booth. And ultimately, with Octane actually having full path tracing on the phone and all these other technologies, light fields and our really good AR capture system, I think we've got something really cool that Unity developers and artists can basically leverage. And the way that we would publish these experiences ideally would just be as Urbach assets. You wouldn't necessarily have to have all of a whole new app published. Like we've been very adamant with when we do talk to Apple about this being something that's really important. And I think that actually is sort of moving the needle a little bit. Apple has been a big proponent now of USD, which is something we can support as well in Urbach. And you're seeing different material, pipelines come up around USD, such as Material X or NVIDIA's MDL. But I think ultimately my sense is something like the universal material, which is pretty much universal, with things like OSL, which is a standard that's been around for a while and that all production renderers are supporting. That seems like the future of object and asset interchange. And in fact, this is the first image of all these things set up at our booth this morning, which you guys are more than welcome to check out. And on the left is the Vulkan backend for render, which is on the 2 Quadro RTX cards. And then that iPhone demo is running also on iPad, on the MacBook, and on the iMac. And unlike our previous efforts to port Octane, or port all of CUDA actually to AMD, the speed that we're getting is really, really good across everything. I mean, we're getting good speed on Intel integrated graphics, we're getting good speed on the AMD card on the Mac, and we're getting, frankly, better speed on the iPad and the iPhone than we are on the Intel GPU. And of course, on the very left with our Vulkan backend on RTX, it's in the 10 billion rays per second range. It's insane. So that is something we've never seen before. I mean, on the last generation NVIDIA card, we were closing into 400 million rays a second. So it's genuinely, we're seeing a 10x improvement, which is just absolutely amazing. So I think we've got a little bit of time for questions if there are any. Thank you. Any questions? Yes.
Okay. Thank you very much for your presentation. I think it is amazing work you guys are doing.
Thank you.
Thank you for that.
I wanted also to point one observation. We actually organized a workshop here at Siggraph on Sunday related to the application of computer graphics for autonomous driving applications. And there was a lot of discussion on how important it is to generate, realistic images for training deep learning systems for vision and so on.
Yep.
So, and I think it's very amazing also the procedural content generation and operating with this. Also the spectral aspect, that would be very important for simulating sensors, for instance, and all that. And one of the problems we have in this community of autonomous driving is the generation of content and scenarios, because we need to generate a lot of data, right, for training these deep learning systems. So one of the functionalities that we would need is to be able to access to the properties of materials from an API. So programmatically, we could change these scenarios depending on. So I'm wondering if you could comment a little bit about what are your plans on this for Unity integration?
So yes, I can speak a little bit to that. First of all, Octane and Unity integration is a long-term effort on the part of both companies, and it's going to be there for a very long time to come for free. And the reason why that integration is so interesting and why we did this very unique partnership with Unity was because you can actually take things like C# and you can drive and program all these things. So there isn't anything inside of Octane that isn't exposed inside of Unity, other than some pieces that we're changing, right? So the only reason why we haven't completely given you the same exact access to the C++ version of Octane is that we're changing that C++ interface, but you have the ability to drive Octane any way you want. You can drive it. We're actually, one of the big announcements I should have mentioned was that the free version of Octane 2018 for Unity and even Octane 4 will be 2 GPUs, and you can use one or both of those for denoising, for other things. So you can use Octane for Unity to generate renders. You can do all these things with it. It's fully programmable by design. And I think that those kinds of things are great. Like the only other option is to take the Lua scripting system in Octane and drive automated jobs with that. But any way that you want to use Octane for Unity, it's free on 2 GPUs. The $20 a month subscription gives you up to 20, and then you have the cloud service for basically unlimited amount of compute for usage and usage-based credits. Cool. Any other questions? Who's excited about RTX? Yeah. I will say that that 2 years ago at Siggraph, we were talking about Octane on ray tracing hardware. But I think that both for us inside of Octane and also for Unity on the rasterization and ray tracing pipeline, it is a game changer. And I'm really excited to see what the world is going to do with it. But I do see that advancing. I don't think Jensen was wrong. I think that we're about 10 years sooner towards a lot of the things I was mentioning at the beginning of this talk than we were before. So I think it's going to be an amazing few years of creativity and some beautiful content and games coming out of that work in the very near future. Thank you, everyone.